Hello everyone. So in this video, we will be talking about isomers. And to be specific, we will be talking about constitutional isomers. Okay, so guys, constitutional isomers basically mean that you have different versions of a same molecule. What does that mean? It means that I will have the same number of carbons and hydrogens, but their connections will be different. Okay, so basically, if I draw 4 carbons like this in a straight chain versus I draw 4 carbons like this, you have made what we call isomers. Okay, so isomers are molecules which have the same number of carbon and hydrogen, so they have the same molecular formula. So same molecular formula, but their structures are different. The connections are different. They have different structural formula. So when you actually draw it out, they will look different. So guys, when you have 4 carbons, we're talking about the simple alkane. So C4H, how many hydrogen guys will there be? You don't have to actually draw them here. You should be able to tell from the general formula that we learned. If carbon is 4, hydrogen will be twice plus 2. 4 times 2, 8, 8 plus 2, 10. So yes, both of these, if you actually draw the hydrogens on them, so this will be CH3, this will be CH2, this will be CH2, this will be CH3. 3 plus 3, 6, 6 plus 2, 8, plus 2, 10. So this is C4H10. And is this also C4H10? You see, this is, again, guys, whenever you have carbon, it needs 4 bonds. This carbon is already bonded to 1 carbon, already has 1 bond, so it needs 3 more, which comes from the hydrogen. This carbon here has 3 bonds, and there's 1 hydrogen sitting on this guy like that. Okay, you can write like that, or just to understand, we know that it's just sitting here. Okay, so we got 3 plus 3, 6 plus 3, 9 plus 1, 10. So both of these molecules are C4H10. So they have the same molecular formula, but their connections are different. Here I have 4 carbons in a straight chain. Here I have 3 carbons in the straight chain, and 1 carbon is actually sitting on the central carbon. So you can think of this, guys, that in this molecule, when you have 4 carbons in the straight chain, if I detach, remove this carbon from carbon number 3, and I put it on the second carbon, then you have made what we call the isomer. Okay, now one thing to understand, guys, here is just twisting the straight chain into a bent chain does not make it an isomer. So this molecule number, let's say if this is molecule number 1, and this is molecule number 2, and this is molecule number 3, then understand that 1 and 3, they are identical molecules. They're same. They're not isomers. And guys, you will be asked this question on the exam. I'll give you 2 structures and ask you, are these isomers or not? So guys, 1 and 2 are isomer of each other, but 1 and 3 are identical. Okay, and at the same time, we can say that 2 and 3 are isomers because their connections are different. So guys, just taking this carbon and, just twisting it down here, bringing it here, does not make it isomer. For isomer, you need to, change the attachments. You will have to remove this carbon 4 from number 3 and put it on 2. That's what you did here. That's when you make an isomer. Okay, so your isomers usually will have different number of carbons in the straight chain. If you guys try to answer that here, in the straight chain, in this one, how many carbons do we have? I have 1, 2, 3, 4, right? In this molecule, how many carbons do we have in the straight chain? We have 1, 2, 3. Right? Guys, look for the longest chain. Here, longest chain is 4 carbons. Here, the longest chain is 3 carbons, and this is a substituent, right? In this molecule number 3, you see actually the straight, does not have to be a straight chain. The longest chain actually here is 4 carbons. This is 1, this is 2, this is 3, this is 4. It is a continuous chain, right? So this molecule is actually the same as this molecule. Okay, but here in molecule number 2, you have 3 carbons as the longest chain, and this is a substituent. Okay, now you should be able to tell by now, guys, if we have more and more carbons, you will be able to make more and more isomers. If I try to make more isomers of this molecule number 1 or 2, actually there will be nothing much more I can do. The trick to make isomers is to keep making the parent chain smaller and smaller. So if I start with 4 carbons straight chain, then I change into 3 carbons longest parent chain and made one of the carbon substituent. If we do this more, let's say we draw 2 carbons and then I put a carbon here and I put a carbon here. Is that an isomer, guys? Try to answer that. Is this molecule any different from molecule number 1? Is it? Try to think about this. Again, this here, guys, this molecule number 4 actually is nothing but just twisting this carbon 4, bringing it down here, and twisting this carbon and bringing it down here. That's all what you have done. You still have, if I ask you how many carbons do we have here in the longest chain, you still have 4 carbons in the longest chain. It is a continuous chain. Again, remember, this is not continuous. 1, 2, 3, and this is separate. Here, this is not separate. This is 1, 2, 3, 4. So if this was butane, this is also butane. This is also butane. This here is actually 2-methyl propane. You will always notice when you're not able to figure out whether you're dealing with an isomer or identical molecule, try to give them the name. If you name them, you will be able to figure out whether they're the same molecule or not. Okay. Now, another thing you want to learn is the more carbons you have, the more isomers you can make. So let's say if I have a carbon here, let's take an example, but this time I have 5 carbons, example. Okay, so if I have 5 carbons and now I try to make an isomer, guys, remember that the trick is that you want to lower the number of carbons in the parent chain. So if instead of drawing 5 carbons, if I draw 4 carbons in the main chain and somewhere else I put a carbon, not here, because that will be the same thing as drawing 5 carbons in the parent chain. If I just do this, guys, is that an isomer? No, it's not. Okay, your longest chain is still 5 carbons. So this is not an isomer. So let me remove this. So for molecule number 1 and 2, these two are isomers of each other. Okay. Now, what else can we do? Can I do this? Is this a third isomer? Think about this case. So here I have 5 carbons, 1, 2, 3, 4, 5 in the straight chain. Here I have 1, 2, 3, 4 carbons in the straight chain. Here also I have 4 carbons in the straight chain, but are molecule number 2 and molecule number 3 any different? Think about this, guys. Where is this substituent sitting? It is sitting on carbon number 2. Here, where is the substituent sitting? Guys, when I'm counting this, do you see when I'm counting, it's okay. But if I have to number this chain, the numbering is incorrect. Why? Because see, if my substituent is sitting this here, sitting on this side, I should start the numbering from here. Do you see in both the cases, actually this substituent carbon is sitting on carbon 2 and sitting on carbon 2. So molecule number 2 and 3 are actually identical. They are not isomers. Yes, 1 and 3 or 1 and 2 are isomers, but 2, 3 are the same molecule. They have same attachment, okay? So this is like saying you're seeing this molecule from this side, and I'm seeing this molecule from the other side, flipping it. So that does not change the molecule. Flipping the molecule does not change the molecule. It's still the same molecule, okay? Just a different perspective to look at these two molecules. Okay, so if I have to make an isomer, what other option do I have? So I went from 5. So let me remove this because this is not an isomer. This is not a new isomer. So now I had 5 carbons in the straight chain. Then I have 4 carbons in the straight chain. Let's try 3 carbons in the straight chain. Now what do I do? Where do I put the next 2 carbons so that I get an isomer? Can I do this, guys? What will this be? If I do this, how many carbons this time do I have in the main chain? So I have let me redraw this so it's not confusing. So let's circle the carbons in the main chain. So I have the longest chain like this, right? And if I try to number this, how will I number this? Wherever my substituent is sitting, it should get the smallest number. So my numbering will be 1, 2, 3, 4, like this. So you see my carbon, my substituent is sitting on carbon number 2. Same thing here. My substituent is sitting on carbon number 2. So actually I've drawn the same molecule. What I did is I just twisted this molecule down, right? That's all what I've done here. Remember the previous molecule that I had drawn? So it was 4 carbons like this, and I had a carbon substituent here. So guys, if I just twist this molecule down here, you see I'll get this molecule. So this molecule is still not an isomer. Okay, I mean, it is an isomer for carbon for this first structure, but number 2 and this, they're not isomer, they're the same. Say, whenever you're confused on this, try to name them. What will this be called? This here is a single carbon. This should be called methyl. And this is 4 carbons. 4 carbons are called butane. And this methyl is sitting on carbon number 2. So this guy is 2-methyl butane. Whereas if I try to draw this molecule, try to name this molecule, again, I have 4 carbons. This carbon, again, single carbon. It is methyl, again, sitting on number 2. This is also 2-methyl butane. So guys, understand this, that you cannot have same names for different molecules. I mean, they're same molecule, that's why they have the same name. Okay, so this here, simple 5-carbon chain, this was pentane. You see this molecule and this molecule has a different name, so they're isomers of each other. Again, of course, they have the same number of carbons. That's the main condition, first of all. They have the same number of carbon and hydrogens, and they happen to have different names. That's when you know you have a constitutional isomer. Okay, now, but is there, again, a way to draw 3 carbons and still make an isomer? Yes, there is. Try this one, guys. This one here, look for the longest chain. This is the longest chain. This is the parent chain. This is a substituent and this is a substituent. What will this guy be called? So this is carbon number 1, 2, and 3. I have 2 methyls sitting on carbon number 2. So this guy is 2,2 dimethyl, and for 3 carbons, you call it propane. This is now different from the previous molecules that we have drawn. Okay, so you saw we have 2 isomers earlier. This is our isomer number 3. So this has 5 carbons in the straight chain. This has 4 carbons in the straight chain, and this one has 3 carbons in the parent chain. And these 3 are then isomers of each other. Okay, so you saw earlier we were only able to make actually 2 isomers, so for C4H10, right? Because this 4th one and the 3rd one, they're actually the same as molecule number 1. So we just had this, oops, sorry about that. So we had this molecule and this molecule as actual isomers. Here, I have this molecule, and this molecule here. They are now unique isomers, okay? This was not a unique isomer. This was actually the same as molecule number 2. So now we have 3 isomers. So you notice more carbons we have, more possibilities of having isomers, constitutional isomers. Okay, so that is it for this video. If you guys will have any questions, let me know.